Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P16BB-00, relates to a low voltage reading in the Alternator B terminal circuit of the Honda CR-V 2023 and later models. This code indicates that the Powertrain Control Module, PCM, which manages engine performance and emissions, has detected an issue with the voltage levels being generated by the alternator. In this context, the alternator is a critical component responsible for charging the battery and powering electrical systems when the engine is running. The PCM monitors various inputs, including power supply from the alternator, to ensure they are within a specified range. If the voltage levels fall outside this range, the PCM will log this fault and store the DTC for further investigation. Addressing this issue is essential to maintaining the electrical system's integrity and ensuring that components receive sufficient power to function correctly. The DTC P16BB-00 indicates a problem specifically with the Alternator B terminal circuit's low voltage. The first key component affected is the Powertrain Control Module, PCM, which interprets signals from various components, including the alternator. The PCM's role is to manage vehicle performance by regulating engine functions and processing diagnostic data. The alternator, located typically on the front side of the engine, generates electrical power necessary for the vehicle's electrical system when the engine is running. The Alternator B terminal connects the alternator to the vehicle's electrical system, allowing current to flow and charge the battery. A low voltage condition at this terminal can lead to reduced electrical power, impacting everything from the engine's performance to the functionality of accessories. The examination of these components is crucial to diagnosing the underlying issue related to DTC P16BB. Several potential causes must be considered when troubleshooting the DTC P16BB-00. First, a faulty alternator may not generate adequate voltage, causing the PCM to register this as a low voltage condition. In this case, the alternator may be malfunctioning due to internal wear or failure of its diodes. Second, bad connections, particularly at the Alternator B terminal or its connectors, can create an open circuit or high resistance, resulting in incorrect voltage readings. This includes loose, corroded, or damaged terminals that fail to conduct electricity properly. Lastly, wiring issues, such as frayed or broken wires in the circuit leading to the alternator, can also lead to a decline in voltage. Each of these potential causes will need thorough inspection to determine the precise source of the issue. Several symptoms may indicate an issue related to DTC P16BB-00. Drivers may notice warning lights illuminated on the dashboard, particularly those indicating battery or electrical system issues. Dim headlights can serve as a visual cue, suggesting insufficient voltage is reaching the lighting system, often due to a failing alternator or poor connections. Other electrical malfunctions may occur throughout the vehicle, affecting systems dependent on stable voltage, such as heating, cooling, or infotainment systems. In more extreme cases, electrical components may fail to operate altogether, leading to additional complications. Recognizing these symptoms early is vital for timely repairs and ensuring reliable vehicle operation. The first step in troubleshooting DTC P16BB-00 involves starting the engine and assessing its operating conditions. It is crucial to replicate specific conditions to ensure accurate diagnostics. For this step, turn on the air conditioning and set the temperature control to the maximum cooling setting. Additionally, the blower fan should be set to maximum speed, headlights switched to high beam, and the rear window defogger turned on. These settings create a high electrical load, which will help in evaluating the alternator's performance under stress. Let the engine reach 2000 RPM for 1 minute without any load, meaning the vehicle should be in either park or neutral. This phase reveals whether the alternator can maintain appropriate voltage under demanding conditions, which is critical in confirming whether the alternator is functioning correctly. The second troubleshooting step focuses on inspecting the ACG plus B circuit. Initially, ensure that the alternator B terminal is disconnected to prevent any erroneous readings. Check the voltage of the circuit under the ignition mode, IG, to confirm it is showing normal conditions reflective of 12 volts from the vehicle's battery. This circuit is essential for the alternator's power supply, and any abnormalities, such as low voltage, could indicate an issue in the circuit's integrity. If the readings are abnormal during your inspection, it suggests a problem exists within the wiring or connections leading to the alternator. This step is vital for isolating whether the alternator is functional or if the circuit itself is at fault. The third step in troubleshooting DTC P16BB-00 involves examining the connections and terminals associated with the alternator. Focus on the alternator B terminal, the alternator itself, and also check the fuse holder A that is part of the ACG_B line circuit. This systematic inspection is crucial to identify any loose, damaged, or corroded connections that could be compromising the voltage supply. Ensure that all connectors are securely attached and make sure there is no visual evidence of deterioration or shorting. The fuse holder should also be inspected to ensure that the fuses are intact and functioning properly. An abnormal condition in any of the connections or terminals indicates that the electrical circuit is compromised and must be repaired to restore proper functioning. The fourth step requires thorough inspection of the alternator itself. If the previous inspection steps indicated that both the ACG plus B circuit and its connections are functioning correctly, it is necessary to focus on the alternator's operational status. This involves checking the alternator for any external signs of wear or damage, including the casing, electrical connections, and belt condition. Moreover, utilizing diagnostic tools may help in evaluating the alternator's output voltage under load conditions, confirming if it meets the manufacturer's specifications. If the alternator fails to generate the necessary voltage, it is likely the root cause of the DTC P16BB-00 condition. A faulty alternator may require replacement to ensure the electrical system operates effectively. After completing the necessary repairs based on the diagnostic steps, the final phase is to verify the success of the repairs. Begin by clearing the previously stored DTC codes from the Powertrain Control Module, PCM. This is essential to reset the system and ensure that the vehicle is not still showing signs of previous issues. Once cleared, perform a test drive under conditions similar to those outlined during the troubleshooting procedures, watching for any warning lights or electrical malfunctions returning. Monitor the voltage output from the alternator as well to ensure it remains stable and within the specified range. This confirmation step is crucial to guarantee that the DTC P16BB-00 does not reappear and that all systems are operating as intended following repairs. In terms of preventive maintenance to avoid future occurrences of DTC P16BB-00, regular checks on the alternator and its associated electrical connections are essential. Periodically inspect the alternator for any signs of physical damage or wear, including its mounting, wiring harness, and electrical contacts. Keep an eye on the alternator belt to ensure that it has the correct tension and is free of cracks. Additionally, regular maintenance should include checking the integrity of electrical connections throughout the circuit, especially the alternator B terminal and fuse holder A. This proactive approach helps in identifying potential issues before they escalate into more significant electrical system problems, ensuring the longevity and reliability of the vehicle. In conclusion, understanding DTC P16BB-00 and its implications is crucial for maintaining the electrical integrity of the Honda CR-V 2023 and newer models. This code denotes a low voltage condition in the Alternator B terminal circuit, which can lead to significant issues if not addressed promptly. Following a systematic approach to diagnostics is vital, as it not only helps pinpoint the cause, but also ensures that all relevant components are thoroughly examined. From checking the alternator's performance to verifying circuits and connections, each step plays a pivotal role in resolving the underlying issue safely. Adopting preventive maintenance practices will further protect against future occurrences of this DTC and enhance overall vehicle performance. Awareness and timely action are key to sustaining the health of the vehicle's electrical systems. Please like and subscribe to the channel. See you next time.